Welcome to this video on software engineering, the basics. In this segment, we will introduce you to the world of software engineering and its importance in today's digital age. Software engineering is the process of designing, developing, testing, and maintaining software. It involves the application of engineering principles to software development, with the goal of creating high-quality software that meets the needs of users. Software engineering is a critical field in today's world, as software is used in almost every aspect of our lives. From mobile apps to desktop software, from web applications to video games, software is everywhere. And as software becomes more complex, the need for skilled software engineers becomes even more important. So, what exactly does a software engineer do? A software engineer is responsible for the entire software development process, from initial design to final testing and deployment. They work closely with other members of the development team, such as designers, developers, and testers, to ensure that the software meets the needs of users and is of high quality. One of the key principles of software engineering is the use of a structured approach to software development. This involves breaking down the development process into smaller, more manageable tasks and using tools and techniques to ensure that each task is completed efficiently and effectively. Another important principle of software engineering is the use of best practices and standards. This includes using established coding standards, testing methodologies, and project management techniques to ensure that the software is of high quality and meets the needs of users. In the next segment, we will take a closer look at the software development process and the different stages involved. So stay tuned. In this segment, we will take a closer look at the software development process and the different stages involved. The software development process typically consists of the following stages. 1. Requirements gathering. In this stage, the software engineer works with the client or end users to identify the requirements for the software. This involves understanding the needs of the users, the functionality required, and any constraints or limitations that need to be considered. 2. Design. Once the requirements have been gathered, the software engineer will begin designing the software. This involves creating a detailed plan for how the software will be developed, including the architecture, data structures, and algorithms that will be used. 3. Implementation. In this stage, the software engineer will begin writing the code for the software. This involves translating the design into actual code, using programming languages and tools. 4. Testing. Once the code has been written, it needs to be tested to ensure that it works as intended. This involves using a variety of testing techniques, such as unit testing, integration testing, and system testing. 5. Deployment. Once the software has been tested and is ready for release, it can be deployed to the end users. This involves installing the software on the user's devices or servers, and ensuring that it is configured correctly. 6. Maintenance. After the software has been deployed, it will need to be maintained and updated over time. This involves fixing bugs, adding new features, and ensuring that the software remains compatible with other systems and technologies. Each stage of the software development process is critical to the success of the project. By following a structured approach and using best practices and standards, software engineers can ensure that the software they develop is of high quality and meets the needs of users. In the next segment, we will take a closer look at some of the tools and techniques used in software engineering. So stay tuned. In this segment, we will take a closer look at some of the tools and techniques used in software engineering. 1. Integrated Development Environments (IDEs). IDE are software applications that provide a comprehensive environment for software development. They typically include a code editor, debugger, and other tools for testing and deploying software. 2. Version Control Systems (VCS). VCS are tools that allow software engineers to track changes to their code over time. This makes it easier to collaborate with other developers, revert to previous versions of the code, and manage different versions of the software. 3. Testing Frameworks. Testing frameworks are tools that allow software engineers to automate the testing process. This includes tools for unit testing, integration testing, and system testing. 4. Agile methodologies. Agile methodologies are a set of principles and practices for software development that emphasize collaboration, flexibility, and iterative development. This includes practices such as Scrum, Kanban, and Extreme Programming XP. 5. Continuous integration and continuous deployment CI/CD. CI/CD is a set of practices for automating the software development process. This includes tools for automatically building, testing, and deploying software, which can help to improve the speed and quality of software development. 6. Cloud computing. Cloud computing is a technology that allows software engineers to access computing resources over the internet. This includes tools for hosting and deploying software, as well as tools for managing and scaling applications. By using these tools and techniques, software engineers can improve the efficiency and quality of their software development process. They can also collaborate more effectively with other developers and ensure that their software meets the needs of users. In the next segment, we will take a closer look at some of the challenges and opportunities in software engineering. So stay tuned. In this segment, we will take a closer look at some of the challenges and opportunities in software engineering. 1. Complexity. As software becomes more complex, it becomes more difficult to develop and maintain. This can lead to longer development times, high costs, and more bugs and errors. 2. Security. With the increasing use of software in critical systems, such as healthcare and finance, security has become a major concern for software engineers. They need to ensure that their software is secure and protected against cyber threats. 3. Diversity. Software is used in a wide range of industries and applications, which means that software engineers need to have a diverse set of skills and knowledge. They need to be able to work with different programming languages, platforms, and technologies. 4. Innovation. Software engineering is a rapidly evolving field, with new technologies and techniques emerging all the time. This creates opportunities for software engineers to innovate and create new solutions to complex problems. 5. Collaboration. Software development is often a collaborative process, with multiple developers working on the same project. This requires effective communication and collaboration skills, as well as the ability to work in a team environment. 6. Ethical considerations. With the increasing use of software in critical systems, software engineers need to consider the ethical implications of their work. They need to ensure that their software is designed and developed in an ethical and responsible manner. Despite these challenges, software engineering also presents many opportunities. Software engineers have the ability to create innovative solutions to complex problems, and to work on projects that have a real impact on people's lives. In conclusion, software engineering is a critical field in today's digital age. By using a structured approach, best practices and standards, and the latest tools and techniques, software engineers can develop high-quality software that meets the needs of users and helps to drive innovation and progress.